So now you have to come on in for a second because it's going to get dark, but it'll be more fun if it's dark. So just come on in and we're going to actually shut the door. Oops.
You're right there.
And we'll see if you can capture it or not. But so let's shut it really well, maybe even at the bottom, to make it. Yes. Okay. So nobody's scared at this point, right? And it's fairly trivial and simple to use. So do you want to try it? Instead of you looking at something and then describing what you saw, the microscope projects out an image, live image, on any surface, any flat surface. So tons of people can immediately look at it directly. It's very, very simple to essentially use. But what it does is then you're looking at something simultaneously, and that's a conversation. So it's almost as if like a window opens up to the microscopic world. And then that microscopic world should raise questions. And then those sets of questions is really what we're interested in, because it's the same paradigm when you think about in physics. You ask, why is the sky blue? So, why do kids keep asking, why is the sky blue? It turns out that it's fantastic physics to be figured out to answer that question. We're trying to do the exact same thing for microscales. We put the constraints very early on. We said these are the sets of constraints. Those are very harsh constraints. But then those sets of constraints lead you to solutions and choices that you can make. So it's a project that's evolved over the time. And one of the things that has happened is, there are many different designs. It only takes us 30, 40 minutes to come up with a new optical configuration and test it because it's just so tangible. So you can try out a whole bunch of things and then figure out why that works. So there is a lot of trial and error in something like that as a process. But I think our goal has always been this idea of, what if every single kid in the world has a microscope? And that immediately puts a constraint. There are lots of kids in the world. You have to think about how do you make an instrument such that every single person could actually afford it. It's really about curiosity of people. We're not telling them what to do with an instrument. So people come up with ideas, and context is so important for ideas. Like if I grew up in Mongolia or in Kenya or in India or in Alaska, the questions I would ask are very different from, say, Palo Alto. So that's really why it's very important for just letting people explore with really good scientific tools that they can actually afford. I teach at Stanford. I'm a faculty at Stanford.
Okay.
That's correct. Yeah. So my lab is at Stanford. And in fact, the project comes from Stanford, and tons of graduate students and undergraduates from Stanford are involved in the project.